Alright guys, this video is going to be a review over some exponent rules that we've been working on. The question I'm going to ask here is going to look very similar to one we've been doing a lot in class, very similar to the one on the quiz we took on Friday. So as you're working through the questions that are going to pop up, what I need you to have out is your notes from class, the definitions we've done, the examples you've got in there. So if you don't have your notebook handy, go ahead and pause the video and pull that out. I'd get a piece of scratch paper out, something to write with, a calculator if that is going to help you, but I'm not sure you'll need it. But have that out so that way you can actually work through these and get some meaningful practice that's really going to help you. Okay? So, questions on the board here. Determine if each of these expressions are equivalent or equal to y to the fifth power. So I'm going to give you some time to go ahead and look at those 9 expressions. Determine which rule you're going to use, if it's the product, power, quotient rule. Determine how the definition of zero exponents and negative exponents is going to apply. And actually work through these questions that I'm going to pose. Okay, so there'll be several of them. And I'll work these out on the board when you're all done and give you a little explanation. Alright, let's go ahead and take a look at some reasoning here, a little explanation. Number 1, remember the power rule says to multiply, and I oftentimes remember that because a parenthesis separates 2 numbers here. Just helps remind me that I should multiply. So just remember that the explanation y, so this is saying we want y squared 3 times, y squared times y squared times y squared, which is the same if I list out y squared 3 times, 1, 2, 3 of them, and we've got y to the 6th. So multiplying there should have y to the 6th power, 2 times 3. Over here, number 2, 8 y's on top. 1, 2, 3, 4, 5, 6, 7, 8 divided by y to the 3rd, so y times y times y. If we look at how that cancels, and I'm left with 1, 2, 3, 4, 5 y's. It's left with y to the 5th. So remember when we're dividing the quotient rule, you have the same base, we subtract the exponents. So this is y to the 8 minus 3 power, which is y to the 5th. Number 3, definition of a negative exponent. We had something that looked like this up on the board, or in your book, I guess, for a definition. So if the exponent is negative, we can, what I like to say is flip the fraction, or you're going to take your expression from the numerator to the denominator and make it positive. So apply that to here, we'd have 1 divided by y to the 5th power, y to the positive 5. And if I look at what I was originally, my original expression, some people might say, hey, yeah, they're both y to the 5th, but this is just y to the 5th, and if I write that as a fraction, it'd be over 1. This is 1 divided by y to the 5th, so these are not the same. Number 4, y to the 5th to the 0 power. We could look back up to number 1 and say we're going to multiply, so it'd be y to the 0 power, which equals 1. Anything to the 0 power is 1. You could also say, well, I'm not even going to multiply. I know that 0 exponent always means everything it's attached to is 1, so no, not equivalent to y to the 5th. Number 5, remember my explanation number 2, so we're going to subtract. So what I need to do is say this is going to be y to the 2 minus negative 3rd power. Well, I'm subtracting a negative, so that's the same as adding a positive we think of. So y to the 5th power. So that is equivalent to my original expression. Number 6, I'm going to expand this similar to what I've done these other ones. This is y squared, this is y to the third. How many y's do I have? Well, I'm multiplying y by itself 6 times, not the same as y to the fifth. And remember, my rule is I'm going to add the exponents. You just got to remember this is an exponent of 1 in that first one. Number 7, I'm going to remember my rule from number 1, so I'm going to multiply the 2's. So this is the same as y to the 2 times 2 is 4, times y, and we know that's y to the first. From number 6, I know I'm supposed to add those together, so I get y to the fifth power. Number 8, jump back up to my definition up in the corner, and we can go either way, either left to right, or in this case, right to left. So this would be the same as flipping that fraction, we say, and changing the sign on the exponent, which is y to the fifth. Yeah, that's what we were looking for. And number 9, go ahead and add your exponents along the way. So -1 plus 0 plus 5 plus a 1 right here. And we end up with y to the fifth. -1 and 1 is 0, so these two become 0. 0 and 5 all adds up to 5. Okay? Alright, that's the end of the video. I hope you took your time on answering those questions and really benefited from a little bit of review there. And go ahead and keep your eyes open for another video over break. There likely will be another one. If not, we will see you on Monday the 19th. Thanks guys, enjoy your break.